Hi everyone, I'm Diego Navarro, member of the RTL team. In this session, we are going to talk about the new Bluetooth framework, which covers some quite interesting and promising wireless technologies. This framework was introduced in XE7, supporting both VCL and FileMonkey applications. Using it, we can connect with a large number of devices, including desktop computers, phones, watches, glucose meters, scales, and many more. Some of the things we are going to see today are the key features of Bluetooth, also called the classic Bluetooth, how different is compared with BluetoothLE, the low energy or smart. Well, in fact, are totally different technologies. We'll see later the difference. And how we can use these technologies in RAD Studio, using the provided framework and the component for the BluetoothLE. Finally, we are going to see some demos of using both technologies. Okay, so we can start it. First of all, there are two different technologies under the brand Bluetooth, the classic one and the newer BluetoothLE, low energy. Each one has some pros and cons. We use classic Bluetooth for years in our phones and cars to stream music, for instance. This is one advantage or the main advantage of the Bluetooth technology. It's useful for data streaming. It has a high data transfer rates, around 2 megabytes per second. Well, it's a high data transfer compared with the BluetoothLE. It has the standard Bluetooth profiles, like the PAN, that is the personal area network to share our internet connection between our mobile and the computer, the SPP, the serial port profile, and the A2DP to share or to stream our music from our phone to the car. One disadvantage of the classic Bluetooth is that we can connect up to 7 slaves, or we can connect to our device with another 7 ones. And the main disadvantage, I think, of the Bluetooth technology, the high power consumption. This is due because when we establish a connection between two Bluetooth devices, this is a permanent and live connection. On the other hand, BluetoothLE is a new and totally different technology. In fact, the only common part with classic Bluetooth is probably the name. It uses a different set of technical and radio techniques to ensure a very low power consumption. This is the key feature and the main advantage of BluetoothLE. For that, it's possible to have very small devices with this technology, like HeartRate monitors, watches, and beacons. It has a low data transfer rates, less than 100 kilobytes per second, but again, this is not the goal of this technology. It has a connection time very low, just few milliseconds, and we don't need to do the pair process that is present on the classic Bluetooth. The profiles are based on the generic attribute profile. We are going to see later what is this. And another advantage is that BluetoothLE supports a large number of slaves. Here you can see a set of standard approved GATT profiles. Notice the focus on health and medical devices like blood pressure, glucose, and health thermometer. In fact, any device where the power consumption is important and has to send just few bytes of data is perfect for BluetoothLE. GATT defines a set of rules to build any other profile that can be discovered and used by another devices. Okay, what is a GATT profile? A standard LE device has or implements one or more services or profiles. Each service contains one or more characteristics, that is, small pieces of data. You can read, write, or subscribe to the exposed characteristics. To better understand the concept of GATT profile, here we can see how we structure the standard HeartRate profile. It has one mandatory service, HeartRate, that implements 3 characteristics. The first one is to contain the beats per minute. The second characteristic, that is optional, is to contain the location of the sensor, for instance, the chest. This profile can implement another service, that is the device information, to display some interesting data like the model or serial number. Okay, now that we become experts on Bluetooth technologies, let me say what about the implementation of these technologies on RAD Studio XE7. First of all, the requirements. Starting with classic Bluetooth, we need at least Windows 7, and the functionality depends on the used chipset and driver. For instance, we found that Bluetooth with Broadcom chipset are much better than others. The exposed API is very pure and doesn't include profiles functionality. For Android, we have classic Bluetooth support since the API level 5. For iOS, classic Bluetooth is not available because Apple doesn't expose any public API for that. And in the case of the Mac, classic Bluetooth is fully supported. For Bluetooth Low Energy, on Windows we need at least a Windows 8 and the client side is supported, but the GATT server are not supported. There is no API for that. That means we can connect with another LI devices on Windows, but we can build any GATT server. For Mac, we need at least the Lion for the client, and if we want to build GATT servers, we need at least Mavericks. And this is important. Not all Mac hardware is supported. Not all Mac hardware supports the Bluetooth Low Energy. Only the recent models. For iOS, we need at least iOS 5 for the client and iOS 6 for servers, if we want to build GATT servers. But I recommend at least to use the iOS 7 because Apple improved a lot the low energy API on this version, 7 and the 8th one. Again, not all phones and iPads have support for low energy. We need an iPhone 4S or an iPad 3, the first Retina, at least to build low energy applications. And in the case of the iPod Touch, we need one of the 5th generation. For Android, we need at least the 4.3 version, and the client side is fully supported. For GATT servers, we need to wait until the Android 5 version is released. Okay, time to know the new units introduced on XE7. We have System Bluetooth that contains the Bluetooth framework with the Bluetooth Manager and BluetoothLE Manager as key classes, and System Bluetooth Components that contains the BluetoothLE component. This component supports both FireMonkey and VCL applications. Before the demos, I'd like to mention an interesting device that is the Texas Instruments sensor tag. Here we have the website to get more information. It's very useful for development and it's cheap. Includes 6 sensors like the temperature and humidity and accelerometer and gyroscope. And Texas Instruments provides a wiki with enough information to get all data from the sensors. I'm going to use this device in the BluetoothLE demo because it's interesting to know how to connect and manage devices that doesn't implement an standard GATT profiles. With enough information using the framework, you can connect to any BluetoothLE device. Okay, time for the demos. Okay, in this demo we are going to see how to connect 2 devices using classic Bluetooth. In this case, we are going to create a Bluetooth server on my Mac machine, and we are going to send some text from my Android phone. So I'm going to open this application. Here it is. This is the Bluetooth Classic application, include a sample application in XE7. It has some interesting functions, so calling to discover devices, to discover all the Bluetooth devices around, and to do the pair and unpair operations. In this case, I'm going to use the paired devices list. So my phone is actually paired with my Mac machine. Okay, I'm going to use this application to share the screen of my Android phone on the Windows machine. Okay, I'm going to run the application first on the Android machine. Is ready. Well, we create kind of abstraction of the Bluetooth socket like the classic TCP socket. So we have the common use function like connect, like send data on the client, and then on the server we have the accept function to accept connection, and the RAD data. So if you are used to use sockets like on the Unix or Windows AP, it's almost the same. Okay, the application is running on the Android. I'm going to launch right now on the Mac. Here it is. Well, the idea is to I'm going to use with my HTC One X. I'm going to create the server here, a text service. We are to suppose that we are sending text, but it's not required. You can send any kind of data. Okay, that is the. Yeah, now we have the Bluetooth server create, and well, I'm going to send some data, some text from my phone, and then it will appear here. Here it is. Okay, I'm going to right here. Hello from CodeRage. I'm going to click on the Send To button. Here it is. The text is sent. The refresh of this application is not very good. Okay. Here is the text. So now we send this text using Bluetooth. Okay. The code of this application is quite simple. First, from the client perspective, the first thing we need to do, right here in the form show, here is to get the Bluetooth manager using this class function, Bluetooth manager current. Doing this, we obtain the Bluetooth manager of the machine. Next step is to get the adapter. In this case, just calling the current adapter method of the Bluetooth manager. Next step, I need the list of paired devices to connect. This is just to get the get paired devices method of the manager. Okay, so right now I have the manager, I have the adapter, I have the list of the devices, so I'm going to connect. This is done here. First of all, I need to create a client socket. I have the device, my HTC One. I just need to call the create client socket method, providing as a parameter a GGIT. Here is the sample identification for my service. This is I like to compare with the port of the classic TCP sockets. And in this case, we are using no secure communication, so the devices are paired and the security is on the paired processor. We don't need security connection right here. Well, I create the client socket, then I need to do the connection just to call to the connect method of the socket. In this case, all the calls are synchronous, so this socket library is synchronous, so we need to wait until the connection is made, and then I'm going to transfer this string into bytes and call the send data method on the socket. That's all I need to do to send the data to the server. Okay, from the server perspective, it's the same. I need the Bluetooth manager in the same way we obtain the client. In this case, we are creating a thread to continually wait new connection. It's not needed, but it's better. So the first thing to do is to create the server. This is done just calling the server socket method of the adapter. We provide in this case a service name that is a description string on my service. When other devices discover my service, they can see the string I provide here. And then the target identification, that is the same that we use on the client. In this moment, the server is created, so the other device can see my service published. And then, well, we just need to wait to incoming connections. In this case, this is made in the execute method of the thread. First, we are waiting for a connection. This is done with the accept method of the server socket, providing a timeout. We just wait 100 milliseconds for any new connection. When a new connection arrives, okay, I have my socket is not null, then I'm going to read the data. In this case, calling the RAD data method on the socket. When I have some kind of data, right here, I just get the string from the provided bytes and display on the memo. And that's it, all we need to send data between devices using classic Bluetooth. For this demo, I'm going to use the Texas Instruments sensor tag device, that is a standard BluetoothLE device. It has up to 6 sensors, so it's great for development. In this case, in this demo, we are going to use the humidity sensor, the ambient temperature, and the target temperature, that is this sensor, this one. You can point the sensor tag device to any object and it can read the temperature that this object is. And we are going to display the accelerometer data. Okay, I'm going to run the application here. Okay, here it is. The device has one button, just one button, that is pressing the button, make the device go to discover mode, so we can discover the device. Okay, I'm going to press, here it is. I'm going to put the application here and click on find devices. We just need to wait 4 seconds. Here it is. The sensor tag, I'm going to subscribe to data. That is, I'm going to tell the device that we are ready to read all the data from the sensors. Okay. Here it is. We have here the humidity, the ambient temperature, it's a nice day today, and the target. Okay, I'm going to point the target to my desktop monitor, and you can see how the data raise right now. Yeah, okay, until 33 degrees, that is, it's okay. Right now I'm going to point to a glass of water, and you can see how, yeah, that's it, 11 and 12 degrees. And if I move the device, you can see how the values are changing of the accelerometer. Here it is. Okay, so I'm going to power off the camera and take a look to the code. Well, this demo is using the BluetoothLE component that does all the work. It has methods to discover the devices and to read, to write, and subscribe to the characteristics and discover services that are the most common function that we can use. It has some interesting events. When it has no property, we don't need to do anything with the component. We don't need to set up any property. Just drop on the form and use it. The most common use events are the on discover services and on discover devices and on discover services. When we initiate the discover devices event, we provide a timeout, and then when this timeout is reached, the undiscovered devices is fired. Then we have the undiscovered service and uncharacteristic read, that is when a value is sent to us, is sent from the device to our application, this event is fired. Well, when we write a value to the device of a characteristic, the uncharacteristic write event is fired as well. Then we have some other interesting events like the unconnect device, descriptor, undisconnect, and so on. But the most interesting ones are these three. So okay, the first step, that is finding the devices, is here in the Find Devices button, and just we need to call the discover device method on the Bluetooth component. Here we are providing just a 4 seconds timeout to find devices. Next step is, okay, we have some devices found. We are going to the discover devices event, and here we are looking for our sensor tag components. Looking the device name of the phone devices. We have all the phone devices here in this parameter of the event. In this case, well, if we found our sensor tag, we add to the list box. Next step is to discover the services that this device is offering to us, and this is done in the subscribe to data button. In this case, we just get the current device and then call the discover services method of the component, providing as the device parameter the current device. When we have all the services discovered, the discover services event is fired, and here we are searching for our desired sensor. In this case, we are using the temperature service, the accelerometer, and the humidity. This operation is documented on the device wiki. We just need to find this property, the configuration property, write a 1 as a value of this characteristic, and then write this characteristic value to the device using the write characteristic method of the component. You can see here in this line. Then, next step is to find the IRT data characteristic and tell the device that we want to receive this data. This is done by calling to this method, the subscribe to characteristic of the Bluetooth component. We just need to provide the device and the characteristic we found here. The same is done for the accelerometer. It's just change the name of the service. Then we iterate with all the characteristics of this service. Looking for the configuration characteristic, we need to write an 1 to the characteristic, write the value to the device, and then find the data characteristic and subscribe. For the humidity is the same. So okay, we done the first step to discover the device. We found our sensor tag device, then we discover all the services and we configure the device. Next step is to receive the data. Well, when the subscribe to characteristic is called, the device is ready to send data to us. That's made the uncharacteristic rate event fire. We are continuously receiving the data. We just need to, filter by the name of the data, because each data need to be formatted in some kind. This is on the documentation. In this case, because these services are not Bluetooth standard, if these services were Bluetooth standard, you need to go to the Bluetooth consortium and get the documentation about. So well, in this case, we are extracting the data, also doing some calculation. Here in the accelerometer data is just a simple value, and with the humidity the same. Receiving the value from the sensor, and we format and add to the application. So that's it. It's quite simple code, and we can manage doing this way any Bluetooth device. Okay, in this demo we are going to create a BluetoothLE application from scratch. The goal is to discover all the devices that we have around and display them on a list. Then when we make click on one device, it shows all the services that this device contains in another list. Okay, for that I'm going to create a new application. I'm going to add first a button to initiate the discover process, a couple of list box, this one to display the devices, and this one to display the services. Okay, now the BluetoothLE component to do almost all the work. So, I'm going to change this caption, this text, discover. Okay, so the first step is to initiate the discover process. This is done calling the discover devices method of the component. We need just we can filter here using an array of IDs if we want to filter the devices that contains some services that we want. For instance, if we are searching for HeartRate, we can pass in this list the ID of the HeartRate service, and then the component find all the devices and filter those that are or implement the HeartRate service. In this case, I want to discover all the devices around, so I'm going to pass a timeout, in this case 4 seconds. Okay, so when the timeout reaches, the undiscovered devices event is fired. So in this case, I'm going to use this list, the device list that is provided in the event, to fill the list. Okay. I'm going just to, here it is. Okay. Just write all the device name to the list box. I'm going to use the device name property of the device. Yes, that is a description, a brief description of the phone device. So that's it. We don't need anything more. Right now, we have all the devices in this list, and I want, when I click on one, to discover or to find all the devices that this implement. So in this case, I'm going to use another method that is discover services, and I need just, oops, this one, no, this. Okay, I need the device as a parameter that I want to discover the service. So in this case, I can use the discovered devices. Here is, that is a list of last discovered devices. Yes, I need the index. In this case, here is. Okay. Okay. So I have all the devices. When I click on one, I initiate the discover services process. So when the onDiscover services is fired, just I need to fill the list box too, in the same way. In this case, I'm going to use the service list parameter that is provided in the event. We can store this list in another parameter or use the internal list. It depends on the application. In this case, okay. Okay, service. I'm going to use the UID name, that is a description of the phone service. Here is the raw ID, if we need to compare with another. And we have another interesting characteristic. In this case, I like to use just the description. Okay, so as you can see, it's just a few lines of code. We are going to run our application. I'm going to run in this case on OS X. Here it is. I'm going to press the button. Okay, it's in discover mode. Wait for 4 seconds. Here it is. And I'm going to click on the sensor tag, and then in this list will appear all the services that the sensor tag implements. Here is the complete list of all the services. So just the last step is to use these characteristics to read, write, or subscribe to data. For that, the Bluetooth component has the write characteristic or the read characteristic method or the subscribe to characteristic. For instance, if we want to read a characteristic, we need the device and the characteristic. Well, pues, in this case, to get the device is the same that we use here. For instance, I'm going to use the first one, and a characteristic, and I can use the device. I can access to the service. For instance, the first one, and then I can get the characteristic of this service. For instance, the first one. So I can read the value of this characteristic and write and do the usual operations. That's it. So as you can see, the BluetoothLE is pretty straightforward. It's always the same with the documentation of the device or of ISA standard profile. You can go to the Bluetooth Consortium and follow the documentation, and you can manage, you can connect to any BluetoothLE device with just few lines of code. There is nothing more. Well, that's it for this session. Thank you very much for attending. Have fun with Bluetooth and BluetoothLE technologies. Now, it's time for questions. Again, thank you very much.
Diego, I have a couple questions. Al is online with us too, and Al just did the app tethering where he was using Bluetooth and Wi-Fi. But I think app tethering uses classic Bluetooth, right? Not BluetoothLE, or can it use both?
Right, it's using at the moment classic Bluetooth, because the LE technology is not intended for transmitting data. We have another sample application to transmit data between devices using BluetoothLE, but the bandwidth is so limited. It's over 1 kilobyte per second or 2 at the most. We can achieve any other speed because the technology is so limited. It has a low power consumption. That's a great advantage, but the bandwidth of BluetoothLE is very, very limited. For this issue, we can use on tethering.
And I know you told me as well that the BluetoothLE component can work on Windows 8.1, but the only difference is rather than discovering whatever it can, it only discovers low power devices that you pair using Windows 8.1 Bluetooth devices. Is that right?
It's right. You need to pair prior to use the device on Windows 8. This is the way that Microsoft has implemented this API. I don't know if in future versions like Windows 10 this will change, because it's the only platform that you need to pair the device. On Android, on iOS, on Mac, you don't need to do that. Just discover the the devices, and you can find any device that you have around.
And then I was wondering, you know, you have the timeout for discovering devices, and I was wondering, you were using 4 seconds. Is there a rule of thumb on how many seconds to do the discovery? If you're looking for more devices, you need to put longer times. Is there any guidance for developers?
I think for BluetoothLE with 4 seconds it's enough, because if the device are advertising the service, it's enough with a couple of seconds. But to be sure that we can find all the devices around, 4 seconds it's a good amount of time. We check a lot of any other seconds, and we found that it's kind of the perfect one.
This is that sensor tag device that it's really low priced that you used in some of your samples for temperature and so on, made by TI. This it's called this sensor tag, right?
Right. And it's a very good sample, because this the same chip that this device use, you can find in a lot of devices that you can buy around. So it's great to use this device for the development.
The other device you mentioned to me, if I want to do development and testing on my Windows machine, my Windows 8, Windows 8.1 machine, and if my machine, it doesn't have Bluetooth 4 or BluetoothLE, there's these USB dongles, and several manufacturers make them using I think it was the Broadcom chip. I'll try to find the one I looked for again. But for those of you out there, if you want to do development and testing and your hardware, your computer, your notebook doesn't have BluetoothLE support, like my Samsung Slate had Bluetooth 3, not 4, Diego told me about these dongles, which lets you on Windows 8 and 8.1 find BluetoothLE devices.
Right. Very important. The USB dongles with Broadcom chips are much better than the others. This is because the Windows driver is ready to use the Broadcom chips. Any others like the CSR, you need to use a proprietary driver, and we found a lot of problem using CSR chips and others. The perfect for Windows is to find a USB dongle using a Broadcom, or if you have an Slate that is integrated, usually they have a Broadcom. But if you need to buy any USB dongle, please be sure that is Broadcom. You don't have any problem with this kind of dongles.
Yeah, so for me, Diego mentioned several, and all I did was searched, and I found one for really low price on Amazon. But again, make sure it's Broadcom seems to be really good. You just plug it in. I did that to my Slate, and all of a sudden it installed all the drivers, and then I could see the heart rate monitor, for example, on my Samsung Slate. But otherwise, the other thing I found on an article on, if you have a Macintosh OS 10, you need to make sure that you have the low power. There's if you search under about your Mac, and you go into advanced, there's a property called LMP. Let's see, Larry, Mary, Paul, and if that has a value of at least 0x6, then you have Bluetooth 4 support in your hardware if you have an older MacBook Pro. So the dongles are there, and I just searched and I said BluetoothLE USB dongle Broadcom, and it'll bring up all sorts of them. And it worked great on my Samsung Slate tablet, which only had Bluetooth 3. I just plugged it in, and all of a sudden I could see my heart rate monitor and all the other LE devices we had. The other thing is that for Macintosh, MacBook Pros, or Mac computers, you can go under the Apple About This Mac, go to Advanced, and if you look down, I found an article that said if you look for a property LMP, Larry, Mary, Paul, and if that has a value of 0x6 or higher, then that means your Mac hardware has Bluetooth 4 support built in. And then I could run my HeartRate monitor app on OS 10, and it worked great, even on Mavericks and so on. And so I was searching, let's see, for an article about, just search for, does my Mac have Bluetooth 4? And you'll find a couple articles and that magic parameter. You guys built this great sample that ships with XE7 called Explore Devices LE. It's in the samples C++. I think it's Sensors and Devices or Devices and Sensors Bluetooth folder. And it's called Explore Devices LE. And it's a nice browser. It's similar to one of the samples you showed, Diego, where you could get a list of all the BluetoothLE devices found, then all the services that are available, and then the characteristics that are available. So it's a great, with source code, nice browsing, searching example to find all the LE devices that it can find and to start exploring. We use that Explore Devices LE to figure out the characteristic of and service for this scale that we had that was non-GATT or Bluetooth Smart Standard. And then with Diego's help and Jim's help, we figured out which characteristic was giving us the weight so that we could then display whatever weights we put on the scale.
Right. It's a great sample application to learn how to use the BluetoothLE framework, and even to work with a new device just to check all the services and characteristics that can offer with each new device. We usually use this application to see what we can do with a new device.
So if you go to SourceForge and those are installed when you install XE7, go to RAD Studio XE CPP. I think it's in Mobile Samples, Device Sensors and Services, Bluetooth, and there's several examples. There's a heart rate monitor that the team has built. Classic Bluetooth basic app is there. Proximity sensor, proximity client and server. I guess the sample that we have online that you can just use. Oh shoot, I went past it. Maybe we haven't built the. Oh, I'm lost. Yeah, hold on, I can do this. Let's go back here. Let's go here. Mobile samples. There we go. Okay, so Bluetooth Explore Devices LE. That's the Pascal version, but you can just build it and run it. I guess I'll need to or get somebody to build the C++ version, unless it's been checked in or it's on its way. I'm not sure, Diego. Do you know a C++ version of Explore Devices LE?
Right. Even if a device is not implementing a standard GATT profile, because of how BluetoothLE is made, is just so simple. So they use services, characteristics, and just to read and write, we can use with our framework. So probably we can use any device that is available, unless they don't document what service are exposing or encrypt the information or something like that. But this is not usual. It's not usual, not the usual way to offer a device.
Yeah, what I found is when I'm looking for a possible device, I go to the manufacturer website and see if they have a developer subsite or if they have an API documentation somewhere. And then that sometimes provides information, or if they have a developer forum, for example. I put this link here and I put it in the chat window. This is on the Bluetooth organization site, and they have this site with this. They use these logos, Bluetooth Smart Ready. So if a tablet, a computer, a smartphone, or whatever has the Bluetooth Smart Ready, then it says that device comes with support for BluetoothLE. So if I went down to Samsung, I didn't see my a Samsung Slate in there, but things like Galaxy Series and let's see what Apple, a MacBook Air Pro, iPad, and they said 4th generation and so on, and iPhone 6 Plus and 4S had the support, but not a 4 or a 3GS. And then down a little further on the page, they have this logo, Bluetooth Smart, and Bluetooth Smart lists a bunch of companies. These companies, if they use the Bluetooth Smart logo, they can only use that if they have, for the types of products, they have standard GATT support so that's where we found things like I found that the Polar, let's see, where is it? Where was my Polar? That my Polar H7 heart rate monitor was GATT standard, and I could use the same app that Diego used with, I think you or Serena had the Zephyr heart rate monitor, ZEPHYR. I didn't see that one listed, but maybe it has many different names. But this is that said that it had that it was Bluetooth Smart, and that it had a standard GATT profile for heart rate monitors. So you can look at some of these blood glucose and so on, and these companies can only use that Bluetooth Smart logo. So if you're thinking about buying some devices to do some things besides that great TI system, look for the Bluetooth Smart logo, right? And then you'll have a good experience discovering them and having them work just right out of the box with the exploring, with names and the samples. And the Bluetooth developer site has all the specifications and the standard UUIDs and the types of the characteristics of the characteristic data. It's all documented, so you can go there and find it. I did have one other question, I guess. But maybe others have questions out there in the C++ room. I know the question, Diego, and we talked about this before. People always ask, what about beacons? What about iBeacons and alt beacons and Android beacons and so on? Those are BluetoothLE devices as well, right? But the APIs on the different platforms are different than the standard Bluetooth or BluetoothLE frameworks. Can you talk a little about beacons and maybe what we're trying to do in the future?
Okay, beacons is a kind of a special case because they use the advertised data, that is a very small amount of data that you can share with another device just to discover. So they use the secret of the beacons that has a very, very low power consumption. Probably you can get beacons with enough battery for 1 year, even for 2 or 3 years, because they don't offer they have 3 operation modes. The default one, that is the typical phone on beacons, they just use the advertised data, so they don't offer any service, any characteristic, just the advertised data that you can find when you begin or start a discover process. So in this advertised data you have just the identifier of the beacon. There is 2 identifier more, that is the major and the minor. That is kind of identification of the beacon. So you can have on your organization a lot of beacons, and you can distinguish this one from others using the major and the minor. You can, for instance, assign you have several buildings of your organization, so you can assign to one building the major number of 1, to another building the major number of 2, and then inside these buildings you can assign the minor version for a room or for any other any other way that you consider. So the process of working with beacon is just to start discover, read advertised data, read the UID that you are looking for, and reading the major and the minor. With that, and with the RSSE number, that is the power you receive the beacon, you can calculate the approximate distance that the beacon is, and you can discover what beacon is what is near of our position. So we are improving the Bluetooth framework to work with this technology on iOS, on Android, and Mac. Windows we can use because they don't expose any function to access to the advertised data. Even in Windows 8. So at least for these platforms, for all the mobile platform, Windows and Android and iOS, and even on Mac, we can use in the future. With we can work using a component. We can work with beacons.
Understanding beacons, or iBeacon is the name that Apple uses, and it's connected or extends to the location services in iOS instead of Bluetooth. And then there's this thing called AltBeacon, which is sort of an open interoperable beacon specification that some people are using, and it has a lot of information as well. I'm not sure on it's in Apple it's an extension to location services, but you were saying I think it is on Android it's related to advertising, is that right?
Right. On Android we can use the same Bluetooth framework, the same Bluetooth function, but on iOS they use another totally different framework, that is the co-location. So for Apple devices, the beacon is kind of GPS for internal or for inside building. So we need to abstract this and use as a component.
Okay, I mean developers could call into the APIs of the operating system if they need to do something now, but you're working to provide a really nice beacon component, which will be great for everyone, that would work across platforms that support these kind of beacon devices, right?
Right. They can use the co-location framework until we have the component right.
Excellent. Well, Diego, I know it's probably 10 p.m. now, but thank you so much for being with us so late into the evening over there, and tell everybody in our development offices over in Spain that all the work they're doing is fabulous, and everyone should know who's in this track and in the Delphi track. The team, not just in Spain, but the RTL teams here in Scotts Valley and FireMonkey and in St. Petersburg and everywhere. These guys and gals are working overtime to provide all this great component and RTL interface support that you get to use, and are on the forefront of all the things that are coming out in devices and beacons and platforms. So again, Diego, please pass along to Jose and everyone in Alicante my heartfelt thanks for what you do to help me try to understand it, but for all our customers to be able to have all this access to this great technology. It's
a pleasure, and we continue working very hard for doing new things, new and very exciting things. Thank you very much.
And all these devices, I mean, the amazing things that developers will be able to use C++ Builder today to talk to all these Internet of Things devices, and even more in the future.